My name is Björn, and I'm at RITMO. And I wanted to show you this jukebox with research data. And this data comes from experiments with applying evolutionary algorithms to the synthesis of sounds, synthesis and discovery of new sounds, where one sound can become the parent for a new sound by mutation. And the algorithms I'm looking into, they are not optimizing for any specific goal, but rather encouraging or promoting diversity. So a sound classified with a specific set of characteristics can later on become an ancestor for sounds with a set of completely different set of characteristics. So there can be many different evolutionary paths during the process. This is called quality diversity search. We've been running these algorithms with different configurations to try out which one is the best, and that has produced a lot of data. And we will be analyzing this data by producing plots, for example, graphical plots and so on. But of course it's also interesting to actually hear what sounds the algorithms came up with. And so this, that's the reason this Explorer was created, to kind of open up the data for us and you to discover, to search through the discoveries and hear if you find something interesting. So I'm going to go briefly over the features of this Explorer. So it's web-based, and here at the top we have a slider for choosing the different evolutionary runs. And each run usually takes around a day or two, even though it's just 100 or 200,000 iterations. And maybe just to let you hear some sounds. It's actually not working too well, it seems. Okay. This happened yesterday when I was trying it. It's clipping the sound. Yeah. And earlier today this worked also. So that's unfortunate. So you have to filter out these clips of the sounds. But for each evolutionary run, I could actually use the computer demo it. But for each evolutionary run, there are classes. So currently we're using a pre-trained classifier, and to kind of form the current selection plan pressure. So for each evolutionary run, we can scroll here through the different classes. And many or most of the classes aren't really musically oriented, but some of the elites or some of the discoveries within the classes can actually be used in some musical context. But there are a few musical classes for instruments. So if I search like for a violin, yeah, I have two ends. Here we go, I guess. So these are nice sounds, and they resemble a violin in some cases. Yeah. So here we have these sliders to kind of easily access the evolutionary runs and the classes within each run. And the third slider here is to navigate through the history of the evolutionary run. Oh, this is bad.
Would it work better on the laptop?
Yeah, maybe I should try that actually. Yeah,
why not?
Yeah. This is, yeah. I actually would prefer my laptop. Yeah. There we go. So where were we? Yeah, so these top sliders are for navigating the different evolutionary runs and the classes within the runs and the generations within the run. And it can sometimes be interesting to navigate back in time and see how parents are coming from different classes. For example, here in tearing, the sound of tearing, the parent is coming from the class crackle. But if I go back in time, the elite at iteration 39 came from a mutation of an individual in the class shuffling cards. And this kind of demonstrates how the quality diversity search is working, where an individual in another class and often a completely unrelated class becomes, after mutation, an elite in another one. But all these combinations of evolutionary runs and classes combined produce a lot of sounds, tens of thousands. So we have 87 here and around 500 classes. So even though it can be interesting to drag those sliders, it can also be nice, I think, at least to have automated playback. So you can't just passively listen to what the algorithms came up with. And I have actually taken a walk with this on my phone and so many sounds are kind of aggressive, but in some cases you can find some hidden gems in this, I think, at least. And you can do it randomly or sequentially by pressing this toggle for random. But then you can also manually interact with the sounds by pressing this typical play button. And if you find some rhythmic sounds, you can play them on repeat. This is not really a rhythmic sound. If we search for a drum. Then you can kind of observe how it sounds on repeat, basically. And if you find a sound that you like, then you can add it to your list of favorites by pressing this heart. So you can retrieve it later and, in a way, share it with others, because so here I'm logged into an anonymous account, which is created automatically when I visit this page. But if I press this toggle here from everyone, I hear everyone's favorite sound, or have access to, basically, anonymously. Yeah, I still have a filter here, so I only see drums. So this is maybe one example which can be kind of interesting to hear on repeat. And if I want to use some of these sounds, I can download them by pressing this arrow down button here. And that downloads a WAV file to my device, which I can use in whatever software. And each sound is reflected as it was discovered during the process. Its settings of duration, pitch, and velocity are reflected by these sliders here, button. And I can play with those as well to see if some other characteristics are interesting. So if I elongate this sound, and in some cases it makes sense to change the pitch, but in not all cases, for example for percussive sounds. But let's see with this one. Yeah, it kind of pitches down. Yeah, and I can even go microtonal by pressing this int button. So then I have more fine-grained control of the pitch. And the velocity slider is supposed to imitate kind of the effect of hitting keys on a keyboard at different intensities. It doesn't work for all sounds, but in some sounds like piano sounds, it can make the difference. You can try this one. Not really an effect here, but if I search for a piano, maybe this one. No. Not this one. Yeah, here's a slight difference. Velocity. And a little about the rendering. So these toggles are controlling whether the sound is rendered with a remote rendering service, which is using the same technology stack or engine which was used during the evolutionary process. But toggling to local, you are actually rendering in your browser on your device. It's using the same technology. It's using the Web Audio API, but the implementations are different. So there can be slight differences in the rendered sound, which I actually just find interesting, how the implementations differ. Like here. No, this sounds the same actually. But yeah, I'll skip these buttons, but I encourage you to try it out. And please, if you find something interesting, it would be great if you add it to your likes, then I can hear it as well. Here is a QR code, and I actually printed it also.
I think, yeah, there, on the,
yeah.
The note stands.
I was actually had this strange idea that if everyone would play this on alto at the same time, I'm curious to hear how it sounds. But otherwise, if you have questions, then please.
I have a question. Have you ever somehow clustered the sounds together to see, in terms of similarity? You said like it's very interesting to see what evolves from what, so see these pathways. And have you ever like clustered them together to see like, yeah, the shuffling cards agent here was very close to whatever some other class down the line?
Not yet, but I definitely want to try that, and I will be asking you for advice on that, because I know you have done some clustering.
Help or just collaborate.
Yeah, that's definitely an interesting path of research to try that out. So this pre-trained classifier was kind of just like an initial playground to get the technology running.
I really admire the presentation. I mean, despite the AirPlay thing, everything is running smoothly in a browser there, and then here.
Thanks, I'm actually surprised myself. The remote rendering is running on my Mac Mini at home. So every time you play a sound, it sends a request over WebSocket, and, and it works fine on mobile networks. Yeah. But I'm planning to move it on some more permanent hosting.
Yeah, complement to the previous question was also, I don't know if you know Catart.
Sorry?
Catart, the granular synthesis software made by IRCAM. It's a nice, I think the combination of this kind of software with this one would be nice. Like the granular synthesis, it takes a database, a corpus of sounds, and maps them in a 2D landscape based on audio descriptors that you choose. So you have an X and a Y axis, timbral intensity, and whatever, pitch. And then you can navigate the 2D space with all the sounds that you throw at it, let's say mapped out 2D like. So if you find like this 218 sounds, I think in an audio descriptor space like that, you could actually play and navigate them quite easily.
Yeah, that sounds good. I'll ask you maybe later to write it down.
Of course, yeah. So
yeah, I've been thinking about how to lessen the dimensions and what audio features to choose, or should I just use something like an audio autoencoder and play in the encoded space, or do the search even within an encoded space?
Yeah, yeah.
I'm kind of currently all over the place
Okay.
in choosing the next direction. So I really appreciate.
I think the cutout is nice because it's very cutout. Yeah, it's quite simple. It's Maximus P, and you just give your database, choose your audio descriptors, and it maps it out like in 10 minutes. You.
Do you know if it's scriptable? So I would.
I think everything is open. Yeah, it's also open. So yeah.
Yeah, I thought about something like Flucoma.
Flucoma is another. It's a similar approach. Yeah.
And actually, I just made a pull request to Flucoma that has a visualizer that can handle millions of points. So,
Nice.
check that out.
Yeah, yeah.
Or I will like pester you with it
Thanks.
later.
Catout's written by Demo Swartz and it's definitely scriptable. I was going to ask related to that. I mean, it's a bit counterintuitive to have a pitch controller when you're dealing with a lot of sounds which are not fundamentally pitched, and we don't really understand how pitch works anyway. What about MFCCs? Why not have a, moderately large, medium number of bins of MFCC and evolve those?
That's a good idea. So, how many do you think would be?
64 maybe?
So 64-dimensional search space
Something like that, yeah.
from MFCCs. I'm moderately familiar with the term MFCCs.
Mel frequency capsular coefficient.
Yeah, so I've thought about those
Yeah.
a bit, but not too much. So that sounds interesting.
So to me it has more generic appeal, that's why I thought it would be useful addition. I mean, people like pitch of course, but nevertheless,
Yeah.
sometimes it doesn't operate on pitch, as you said.
Yeah. This is kind of an old idea and it definitely doesn't work in all cases. And what I'm doing with the pitch slider is to change the pitch of the audio rate frequencies. So behind this is a compositional pattern producing network, which produces patterns, which I use as audio buffers and also control signals for kind of like a typical synthesizer patch. And when I change the pitch, I'm only changing the pitch of audio rate inputs, but not control rate pitches. But it has been pointed out to me that it might make sense to also change the pitch of those, the control signals. But MFCCs and let them do the binning of the search space.
Yeah,
you're suggesting.
Or predefine them perceptually and then let it evolve those.
Yeah, that sounds good.
Especially with the point you made about the control parameter as opposed to the audio rate parameter. There'd be a nice intermediate step there. People like Henry Cowell a century ago said, why don't we think of rhythm as the same as sound and as the same as pitch? And of course Stockhausen gave the famous demonstration of a sound which is unpitched becoming a pitch. So you could evolve the thing on the basis of a rhythmic structure. The pattern, in other words, could be a rhythmic structure, which then comes out in the sound at the audio rate.
Yeah.
Could be rather nice.
Yeah, that sounds really good. I think we'll have a chat.
Sure.
But often when I'm evolving this, I'm not sure if I'm evolving sounds or whole rhythmical pieces. It can become hard to make the distinction, which is also interesting. So if I drag the duration slider to 60 seconds, sometimes I think I just have this full musical piece running, rather than just a sound for a keyboard. So yeah. And one dimension I want to add is user preferences, and that's why I'm kind of asking you to like stuff that could help me in the future to kind of model what makes sense, because in the space of all possible sounds there's so much noise and so many things you don't like. So it will be good to have something to guide the search in some sensible directions. And it has been pointed out to me to use like surrogate models of user preferences and stuff like that. So all these things I hope to look into soon.
Maybe also complemented to that, I used in the past also like reinforcement learning, where users would just like or dislike a sound, and it would be the algorithm navigating the space based on the likes of. I'm just thinking out loud. That's your application that stimulates thought. So one way of just liking, you could also add a dislike thing, and not only store them, but with the information from a user liking or disliking sounds, you actually have a way to navigate the evolution through reinforcement learning paradigm, like rewarding or punishing.
Yeah, and I'm thinking about how to do that, because for this you saw for these basic sounds I just showed you, there are 100 or 200,000 iterations, and I can't ask a person
to listen,
to give an opinion that often.
Of course.
And there have been recent advances, like you might have heard about reinforcement learning human feedback, which is used for ChatGPT, for example. Whether I should look into something like that or something different, I'm also looking into.
Yeah.
But definitely, yeah, I want to use the preferences. We did a project using FAD distance metrics. I thought about that. And recently I discovered vector databases where you can query kind of on vectorized latent spaces.
Okay.
For similarity, that's one idea. So yeah.
Okay.
Nice, good to hear your ideas and feedback. Thank you.
For me, it sounds like the main challenge is to marry the spectral and the time-based description of a arbitrary length sequence or pattern.
Yeah.
Is like, I mean, it depends on like, is there any like prohibitive limit of dimensions how far you can go in like describing one action or one sound? Like, is there like, let's say, is even 64 like too big for certain processes, or is it okay to go like 2000 or?
Yeah. That's. If you're asking, then I definitely don't have the answer. But that's one thing to figure out, I guess. You could do some kind of parameter tuning, so to have that like a parameter to the evolution processes, and do some automated tuning processes, maybe with some kind of Bayesian learning, because you can't try out all combinations, I guess. And from these sets, we have a little over 100 runs. Those are all just static parameter selections, manual selections for now. So yeah, it's a complex but it's interesting search space.
I'm afraid we have to end the session. Thank you so much, Björn. It was really cool stuff.
Thank you.